Okay, so you already know me, I guess, or for some of you who haven't been there, my name is Liran. I did yesterday a session about Jest. This is why we kind of kidded about it a minute ago. I want to talk to you about Node.js security. So it really actually applies some of it to front-end, JavaScript work that you're doing, but it boils down to a lot of Node.js practices as well. So we're going to talk today a little bit about kind of concepts and ideas that you should have. They're kind of like tips that you can go ahead and just implement in your project when you go back to work or something. So without further ado, I'm coming from Israel. This is how it looks like. Great, right? No, I'm just kidding. I'm working from Tel Aviv. It's actually very fast-paced. I love the city. It's pretty traffic jammed like everywhere else in the world. I love open source. I've been doing that since an early age. Some of you may know me for the work I've been doing in the past couple of years, leading the min.js full-stack JavaScript framework. I kind of shifted out of that a while back and started doing and concentrating a lot of my work around security stuff. So one of them, for example, has been the OWASP project. How many of you have heard about OWASP? Show of hands. All right, so pretty good. I'm happy about seeing so many people have heard about it. So basically, it's a community of volunteers, around the world that is trying to push awareness for security. So they do that by having, organized events, by creating tools, by creating documentations for how to do, best practices for, input validation, output encoding, all of those stuff. So it's been pretty interesting. I'm part of the core project for NodeGoat, which is an educational platform that you can use to learn and experience more about security. We'll use it today at some of the learning activities to see how we can break stuff and then how we can fix them. And I've recently had the pleasure of joining the Node.js Foundation as a member of the security working group, which is a different topic altogether, but very exciting stuff that's happening within the Node.js ecosystem. So I came to security a few years back a little bit further, and when I dived deep into it, part of what I had discovered is that there aren't many resources related, specifically to Node.js and best practices around it and its ecosystem of how to do that. So I ended up publishing a book about it. You're welcome to get it. If you're taking a picture of the slides, usually it costs money, but there's like a coupon code there. You can get it for free. So some of the ideas are from that. That's my son, Ori. He's 4 years old today. As you can see, we take security pretty seriously at home. He's studying CSRF 101 tokens. I may or may not have paid him in some toys to just stand there and be funny. All right, so I want to go back to the magical 2010. All right, we had an amazing experience back there. I call it the Justin Bieber experience. Winning I think the 37th National Music Awards, American Music Awards context. But really, if you go back that far in time and you try to say, what was going on back there, you come up with all of those frameworks, some of which stayed with us today, some of which, thank God that they are gone. But this is kind of what was happening, back there. All of them kind of started to emerge together and grow. And I think if we even try to fine-tune it a little bit further, we realize that Node.js, is obviously JavaScript, but JavaScript is becoming everywhere, right? We're talking about chatbots and IoT and so many things like voice assistant stuff. So it is everywhere, and the fact that it's everywhere is also kind of scary, right? Because that means that JavaScript is over there in your server, in your MongoDB server queries. So it's pretty scary, and I want to start off, with some security horror stories and walk with you about some of the stuff that I'm afraid of. So some of which I hope that you will recognize as being part of the ecosystem, but if not, I'll be happy to just kind of introduce this to you again. So how many of you heard about this package called rimruffle? Raise your hand if you heard about it. Okay, good. So it's an amazing package that was published to NPM back in 2015. If you install it, it does this magical thing. I just love it. This is what it does. It has a pre-installed script to delete your code. All of your disk is gone once you install it. Amazing. So it's really cool if you need to just wipe your hard drive. Just install it. You get it for free. Yes, the wonders of npm. So it actually happened, or maybe it was an urban legend, or maybe it actually happened. And when it did, got shipped into npm, and npm is kind of this open repository everyone can publish, but then there are these kind of problems where people can push malicious stuff into npm, right? And you would read about it from Reddit or somewhere else, and copy paste it, try installing it, and something bad can happen. And not a lot of people have this understanding that something bad can really happen. So it was taken off a few hours back, but it's an interesting experiment that's actually we've been seeing recently, at least for the past year, happening around npm. So fail number 2 is maybe you've been to my presentation and you've heard about validator.js and why you should use it, and it helps you validate and sanitize screen. We'll get to it a bit later. So you go to the GitHub repository and you say, hey, there's like 5,000 stars, looks amazing. Let's install it. It's called validator.js. You try installing it, but what happens is that the package name is actually called validator, not validator.js, right? So at that point, you accidentally installed something else. So this ties back into something called typo squatting, where people are able maybe to publish a malicious package in a similar name. You could be maybe dash, maybe dot, maybe like a typo being made there that you would have done from the terminal, or maybe you copy pasted it without really noticing. And once you install it, again, the same problem where you're installing something that you didn't expect. So it's been happening. I gave you an example here for Socket.io. Probably the numbers kind of change because still a slide from a while back. But even Socket.io and Socket.io, you can imagine that probably Socket.io, the bottom one, is not malicious. But how many people probably tried to install the first one but got it wrong and installed the second one? So if you think these are kind of just stories that I'm making up, all of this has been happening recently. So there was a very, very recent one, a very recent incident around cookies, which a cookies-like management package that was stored, was going to npm. It was malicious. Some modules were using that. It managed to get an entire incident around it. And this is again another story. Not that far back. That I don't know if you know, Kent Dodds, doing a lot of npm and front-end work as well. He has a package called crossenv, but someone installed, created the malicious module, called in a similar way to just crossenv that manages environment variables, and that malicious module was kind of smart, right? It did exactly what the crossenv module actually did as well, so it wasn't anything unexpected, but along the way just took your environment variables and sent them to the cloud. Amazing. So all of these things are really happening, right? So these are horror stories that we should learn from and in fear of it. Fail number 3. So this ties back a little bit to how I think we should do a better job at educating, the next generation, the younger generation, or anyone else that just comes after what we write. And so I was reading this tutorial at SitePoint about building, Wi-Fi dashboard with Node.js, Reactive.js. Seemed interesting. I was seriously, seemingly just reading this article without any intention of talking about it. And once I dived into the article, having a security mindset kind of mess you up, because everything that you look at after you've been having that mindset is like, oh, is this going to be a security problem or not? And this is kind of what happened to me as well. I was looking at this code, and at first glance, this doesn't maybe look very suspicious, but my eyes immediately took me to this child process exe call, which tries to run some command. Granted, maybe it was from some configuration constant that may or may not can be manipulated from outside actors, but still this is very dangerous. I even for this session gave a quick dive into the Node.js docs, and you can say you can see that there's like a note that you cannot, forget, right? Never pass an sanitized user input to this function. Anything is going to be, shell interpreted and executed. It's like a note telling you in the docs, be very careful before you use this. There are better ways to do what you want. Try not to use this unless you really have to. So while people write, those kind of articles, like it's really cool, we're educating each other, that's great, but we have to take into account what's happening here because, maybe another person going into this, saying, oh, that's great, I can run just, shell commands out of Node.js, maybe I'll do it, just copy pasting it and not really understanding the implications of having this in his system. So enough with the horror, let's go start understanding what can we do to make it better. Better. Yes. All right. So to get into this, to get into a hacker's security mindset, just let's view this for a second. All right, I'll stop it here, but hope it was funny. Who knows the movie? All right, cool. Whoever doesn't or will just try to just raise your hands, you should watch it. It's pretty cool. What's really cool about hacking movies, the cyber security scene, all of that, is to see how they kind of visualize, the systems. Everything is like 3D and stuff like that. I don't know. It's like it's pretty boring, I guess, to just show a terminal and someone running exploits and trying to kill it. All right, so the first thing I want to take off, and this is our like notes from the book, is basically security by HTTP headers, and basically this talks about getting SSL and a little bit more security around your site. So I'm going to talk about 3 items, not Destiny's Childs, about those 3 headers that can help you protect and instantly get better security around your website. So the first one being strict transport security. What it does is once you set it, the server just returns it over HTTPS to the client. The client at that point says, well, I'm not going to load anymore any HTTP content. I'm only going to get those HTTPS, right? And like you're forcing it to do it. So you can imagine what would happen if you don't have this, right? And this is like a classic example where, for example, a bank website is on HTTP because it has, ads and it's like marketing page, whatever, and they put like a link with HTTPS to the login, right? But that's still really bad because if I'm doing a met-in-the-middle attack and I'm right there eavesdropping on the connection, I can go ahead and do something that's called SSL downgrading. I can go ahead and just, because this is all HTTP, I can go ahead and change the HTTPS to my own server and redirect users to my server if I'm on the same network. So this is pretty bad. And if you're thinking maybe server-side redirects are going to solve it, so kind of not, because you could be doing the same thing. I could be just intercepting those server redirects and again redirecting them to my server, like the attacker's one. So this is still bad if you think you have an HTTP website, which doesn't have anything sensitive, but then you have an SSL website, So this is why it's bad, and you should not do it. If you have the strict transport security enabled, what happens is, never mind the user doing HTTP, or you have some image resources, CSS, something going on HTTP, the browser is automatically going to try and get them over SSL. So it's kind of a double-edged sword. So like if you don't have those assets available on SSL, it's going to break your site. So you should know exactly what you're doing there. The next one is called X-frame options. It's related to clickjacking and UI dressing attack, and I can give an example of what's going to happen if with this kind of attack. So, for example, imagine like a website for Nutella, and someone wanting to maybe click the free Nutella sample. But what's happening behind the scene is really someone else might have drove you to this a vulnerable website, this landing page. You're not really understanding what's going on there in the address bar. You just want this free sample. But what he's done is maybe took an iframe from the Twitter account, like your Twitter account, and just planted it on the page. And with techniques for JavaScript and CSS, you can just go ahead and place that free sample button right on top, something like deactivate my account or transfer me money or something else. So obviously, it's just an example, and probably you will not be able to do this with Twitter, right? Because they have these X-frame options set correctly. But someone can do this. So if you're developing a website, in web apps, you should know that if you really need someone to use your website as an iframe in some sort, or like your subdomain or something, you should explicitly say that. Because if you do not, then someone can actually use it for malicious things just like this. The last one is content security policy. Relatively being something new, or not so much, I guess, but what it does, it allows you to set some kind of policy for trusted content. So for example, you could go on and say, I do not want to load images from this and that domain, or for example, maybe a better example is, I do not want to render the browser will not render any JavaScript that is not coming from my own files, right? And this already kind of mitigates XSS attacks where people just insert JavaScript code into forms. So I think out of those, probably the third one is kind of the strongest one, and it's getting more like updates on the spec and stuff like that. So you should probably follow that. And it's not so easy also to create a content security policy, because if you again said to the browser, well, don't take anything, any JavaScript that is not from my domain, then if you have some like Google API JavaScript going on, then it's going to break your site, right? So again, you have to figure out how your site works and do it. And what's really cool about the content security policy is you can set a reporting URL. So for example, you're telling the browser, well, any violation that has been made to the content security policy, just send that to this reporting URL. Just like just somewhere where you can log everything. You don't really do anything actively. You just passively log everything, and this is how you study what's going on with your web app, how it's behaving, and then you can actually apply it. So how many of you have heard about Helmet? Okay, so Helmet is a package for like ExpressJS that allows you to set all of those kind of headers, and of course some others as well, and kind of shape up Express so it's a little bit more secure than usual. Obviously, if you're using with Express, this is a must, or there are other libraries that of course compete it, but that's basically it. So I want to show you really how we are able to do this content security policy thing. So okay, so tell me if you're unable to see. Interesting. Interesting, very interesting. Okay. Right, so the app is running on, this is Node.go, the project I told you about, which we can play with it. It's vulnerable by definition, so we can see how things are breaking up. So I'm going to try and log in there to the system. It's like retirement management system, doesn't really matter. We're going to go into maybe the profile and add this script tag, so that maybe we want to. Right. So maybe we want to like kind of do an XSS on the website. So if it's like a form, someone does an input which is very malicious, and at this point, what happens is Chrome actually detected that something bad was going on there around XSS, so it's kind of blocked from loading the page. But if I'll try to load it again, I'm getting the actual vulnerability. Right, so this is an example of how I was able to hack this website, because no one did any input encoding or output encoding or something like that. So the website is at the moment very much vulnerable, right? And we just talked about content security policy. So how would we tell, for example, our website that we don't want to allow any like inline JavaScript getting into the way? So let's just add Helmet. And let's just add the content security policy from Helmet. And we can say everything, all the scripts that would be rendered would be so only allows scripts that are rendered from my domain or my web page. I need to restart this to get it done. Going to relog in. Right, and we don't really see, right, we just kind of mitigated the problem. We don't see this anymore. Like I can go to profile and nothing happens. But what's interesting is if I'd opened DevTools, right, you can see that the actual, just move it to the right. So the actual content security policy kicked in, right? The browser understood what's going on and is now not allowing this malicious inline JavaScript to just go in, right? So just like that, without doing any validation, whatever, you kind of mitigated it. Of course, it's not like a bulletproof solution for anything, but it helps, with adding, security layers to your website. So let's continue with this. All right, so if you just want to stay here, so the site will be available later, or you can just talk to me after it. But you can add many kind of directives. I just focused on the scriptors because that's pretty much the best demo that we can do. But it's like if you haven't used Helmet before, try using it. It's going to help you add some security. This is a very recommended book that you should read and then throw to the garbage. All right, so the next thing is noSQL injections, and we had a talk before from someone from MongoDB, so I'm going to relate to that a little bit. So how many of you have heard about noSQL injections? All right, so you know it's possible. Amazing. So this is an example for doing a query, right, on SQL. But you can see how I kind of try to do it, to do like an SQL injection there, where I'm trying to create true statements into the database by just driving input into the web app and seeing where it can work. And when you're talking about NoSQL injections, you kind of say like, well, how can you change this query from the outside, right? Like what's going on? It's just different objects going on there. There's no string concatenation here, so what's going on? So I want to show you an example as well of how this actually takes place. So we don't really need this. Let me ignore that. And all right, so you can see it. I have an API endpoint. Okay. So I have an API endpoint called API login. And I'm basically sending username and password, and it should authenticate me. So these are the wrong username and password. So I should be able to see, right, that it's giving me this, try to log in username and password thing. When I'm sending the actual username and password for the app, it's gonna be telling me that I'm already logged in. So for example, you can see easy retirement and like benefits and then logout. So I'm already logged in. So this actually worked, right? This is the right password. And when I'm sending something like this, I'm also able to log in, right? The same stuff, benefits and logout. But what did I do here? That's the interesting part. So what actually happened is, so body parser behind the scenes, so body parser behind the scene is able, it's a library that is able to read your the post body payload, and it's of course what it's doing with it is serializing it into a JavaScript object. And when you're doing that, and everyone, if you go into any kind of Express code, you would probably have one of those two lines over there, probably the JSON one on every project. And you need to understand that it's actually serializing input into actual objects in JavaScript. So when you have something like this, where it's like user.find username, now request body username and request body password, what's going on there is the request body password is actually an object. And for MongoDB, this kind of objects like greater than something is an operator that does something. It's like an input string that tells MongoDB to behave in a certain way, opposed to being part of the actual like DSL language for MongoDB selecting stuff. So What happens is I'm actually sending all of these as a JSON, and then this greater than object, of course, password greater than anything and username greater than anything, it's going to match the first account on the database, which is the admin one, and boom, I'm logged in. So there you have it, JavaScript, noSQL injection, going on. And how would we be able to fix that? So obviously validation, right? All right, so I have all of my session information here. I have this handle API login request here. And as you can see, just getting the username and password and sending it to this function callback, which expects username and password, and then checks, well, was it correct or was it not correct? Just handles the actual response. And validate API login does exactly what we saw before, right? It just uses the username and password that it got from the actual request. And a simple fix is probably, if you're actually expecting a string, right, then go ahead and do that. So when I will send this request again, right, it's actually asking me to log in. Right, so just like that, we fixed it because we actually validated input, or we have a schema definition for our input, like you can do with Joy or something like that. So so these are kind of steps that you can do with Node to be able to validate your input and make sure that everything is correct. So validating the length, the type, the actual input type that is expected, and of course parameters binding is if you're doing something like SQL and stuff like that. Yeah, that's how it feels like. So next topic is RDoS. Anyone heard of that one? Regular expression DOS attacks. Okay, so the thing with regular expressions is no one really knows how to write them well, right? How many of you? Okay, I was gonna ask how many of you have written them, but I get it. So everyone, including myself, have written regular expressions before, right? And we're not really masters of that, right? It's kind of a trial and error, reading the docs, what's going on, how should I parse it? It's kind of, for me, it's kind of like writing CSS. So it is this kind of magic that when it happens, you're like, oh, good, I was able to make it work. So since everyone here are expert in regexes, you know what this means? An IP address, right? So it's trying to match an IP address, and when you've written that 1,000 times until you made it work, once it did get to work, you're like, hey, amazing, I did it. Let's ship it to production. But there's a problem with regular expressions. And I want to build something with you together so that we can see what's going on with and why it's bad to write regular expressions. So let's try to build an app maybe that kind of matches song titles, based on regexes, of course. So how would we do it, right? We need to basically match on a specific word set, right? It needs to be like characters, English characters maybe. Maybe there's a number. So we start off with that. We have a matching group. And then maybe we need a quantifier to just add more than just one character because it's song title. And maybe there are spaces involved, so we need to be able to match that as well. And then it's not just one word with a space. We need another quantifier to repeat all of this token matching, right? So we have this plus at the end. So let's try to build it. And I have this online regex tool that you can use. So just building it off. Have a matching group. Right, so I'm gonna give me a song title. What? Britney Spears song title. Come on. Amazing. I think we're connected. I'll show you. All right, cool. So it doesn't yet match it. Right, we need to get this stuff over there. And looks good. So of course, like story done, just push it to production. Except if you have a long enough string, which works well, but then malicious users comes in and they understand regexes and stuff like that, they maybe add something like some kind of token that you didn't expect, and at that point, things are going to blow up, okay? So, there is the front-end track, but at least I know when I'm seeing red messages, it's something bad. Agreed? All right, so there's catastrophic backtracking going on here, and what it means is the actual engine that tries to match the regex for you is trying to aggressively try and match it, but it's unable to really complete it without going into an infinite time to basically validate it. And we can see it if we open the regex debugger here. So it's a pretty long string. I hope we'll get to it, but you can see how stuff works. So it's actually trying to match, specific tokens of the string, and then it goes to the end and to the end and tries to move on until it's able to catch the entire string. So so we're getting to the end of it, and it's trying to match the exclamation mark string, but at the end of the token, but it's unable to find it. So what is it doing is it's backtracking all of the regex pattern and trying to do like char -1, instead of the n, and then trying to go ahead and match that one. And it's not going to do it either, so it's going to go back in again and try to match everything, and it didn't succeed in doing that, so it's going ahead and taking 2 characters back, and then 3 characters back. So all of this process is basically very time consuming and very CPU intensive for the system. And this is what's going to happen on the front end. So on the front end, maybe it's like less worse, it's the lesser evil, because you're impacting maybe the user side of things. But what happens when you do it in Node, right? Node is single threaded. You're not supposed to do any kind of CPU intensive work. Okay, so let me show you what's going on there. All right, so I have this messy. Okay, so everyone just seeing one thing. So I'm timing this node command, which just evaluates this regular expression with the same kind of string and echoing like good to the screen. So it was pretty quick, and you can see that everything went well. But if I go ahead and change it to something a little more time consuming, then it's taking longer time to run, right? Now it's like 1.5 seconds. And the more that I get this string increased, it's going to exponentially take more time to get this done, let alone your node process is now doing 100% CPU. Let's, if we can see it, you see the node eval here with the 99% CPU there. So you've basically just blocked the loop, right? If you have this on your backend, you're doing regexes in a bad way, not specifically maybe this problem, but you now adjust your event loop. So all the requests are now waiting for this to end, which is going to happen in like 1,000,000 years. So it's not really something good to do. All right, so yes, and of course, Brittany being Brittany, it's funny to her. So, so I talked a little bit about DDoS attacks, like the greedy quantifiers. Even simple regexes are susceptible. It's not because it's something long. It's just about how you write it. So be careful when you're writing regexes, okay? And this gets me to regexes being a real problem, right? I'm not making this up. Actually, a few months ago, or actually just recently, we released the Node.js version, which fixed some regex vulnerabilities that were in there. And it's not just the node itself, right? All the ecosystem packages, I'm sure you know one of those packages, and they were vulnerable to the DDoS. And there are more of those as well. They just didn't put in here. So what are regex best practices? And this is what I want you to come out of this session. So there is this document about how to do correct regex. I will send it to all of you since all of you are writing regexes. Please read it. Like really, please read it. Okay, yeah, of course. All right, so you're not going to read it. So that's why I made up other best practices, right? Do not write your own regex. Okay? Because I know you're not going to read the other document, the scientific one, so just do not write it. All right, if you're not going to follow this one, I have another one that's my favorite best practice. Please follow this one, please. Thank you. I see you're learning it. Good. So really, I'm serious about not writing your own regex. But if you are like no way out of it, and you have to write something which is understandable, there are ways to go around it. So first of all, if you're writing something like regex that validates email, base64, whatever, something like this, there's the validator module that we talked about before. Just use it. Of course, it's open source, and it actually had redos problems as well. But then it's not just you looking at your own code. It's like millions of users using it, and if someone is vulnerable, then millions of users are vulnerable, and there will be a quick fix, probably better and sooner than you will do to your own code base, right? So try this. If this doesn't work and you don't need isdate, you need something very custom to whatever your business is doing, then you can try something else that's called safe-regex. It's not perfect. The idea of it is that you can go ahead and give it a regex pattern, and it will try to match it, kind of like this. And it will tell you like true or false, whether it was susceptible or not. It's not perfect, like I said before. There are other tools like that was written in Java, and a recent one I think in Python from someone called Jamie Davis. He has been also a very active security researcher around the Node.js ecosystem. You can just Google that and find it, or talk to me afterwards. I will give you some links. So there are other ways to validate that your stuff is not really susceptible, or you can read this book. It's very good for project managers, if there are any project managers here. All right, last topic for today about security. So we talked, throughout the session about secure dependencies management, and how do you feel about this? Right, everyone has seen this already, and it's always funny, right? And I'll tell you why. Because always it's like more, heavier, because there are more packages in npm. So this is really the problem, right? And if you look at it, now we're all programmers, right? We're writing apps, we're writing code, we're building things. This is wonderful. And when we ship stuff to production, you kind of say, well, this is my code base, right? All of this is my code base, but it's not. This is the reality, right? This is your code, but the rest of it is all of the dependencies that you rely on, right? That's most of the cases. So once you have this understanding of, you're not really bundling only your stuff, you're bundling so much else around it, you need to ask yourself like several very important questions that I hope you will do it after this talk as well. So first of all, who takes care of the risk of those packages, right? Who is auditing them? Who is making sure they're not malicious, that they are not, by accident, not performing well, or by accident being susceptible to redos, or, a bunch of other stuff. And even if you had said, well, I will go ahead and just due diligence on all of these packages, which is, I don't know, maybe possible. Are you able to do it for every single package, for every single release that you will upgrade? It's not something that works out, right? It's not scalable. No one does that. This is the third reason that the third question that you should ask yourself, right? Some contributors could be malicious, right? What does that mean? We just saw, before, malicious modules. So again, npm is an open ecosystem. You can go ahead and just contribute some malicious package and send it to npm. And someone was trying to do it with CoffeeScript as well, right? It's not that long ago, again, right? This is stuff that is happening. So if someone is accidentally doing CoffeeScript wrong, you're getting a malicious package. Python had this as well. It kind of blew up the news. I don't know, with npm, I guess we're kind of used to it. With PyPy, it kind of circled a little bit more heavily. And so far, all of those stuff are kind of reasonable. You say, I will do diligence my packages, etc. But think about something else. What happens if someone was able to compromise the actual contributors publishing stuff, right? That's even scarier. So someone named Chakar, actually, he's a security researcher, also working with a Node Foundation, and he did an amazing just experiment and actual research around the npm ecosystem. And what he found is he was actually able to get access to 14 npm packages, which make up 20% of the npm total downloads. This is crazy. He was actually able to get it, and it was like small packages. I don't know if you know them. Like, do anyone heard about React? Or maybe Express? Did you hear about this one? He was actually able to get twice npm publish access to Express. This is scary, because what if it wasn't him and someone else? So this kind of gets you thinking of like what's going on there. And when you're seeing that, it's blowing your mind, I know. Again, I have some links for like the Gist repo that he actually documented all of it. So all the numbers are there. Just talk to me afterwards. It's an amazing thing of why it happened because 600 users had their password 123456, which is great. I'm talking about research from this document, right? From those NPM packages and compromised contributors. This also makes sense. It's easy to remember to call the password password. This is tricky, right? This is tricky. That's nice. Yeah, and the other problematic thing, which I think if anyone has heard about pawn passwords, you should really just take a look at that one. And your accounts are getting leaked from time to time. You're not getting food anytime soon. All right, so I'm kidding. We're almost there. Accounts getting leaked from time to time, and then people are using those passwords, the same password in other places. So this is also pretty bad. And at this point, you should ask yourself, are my dependencies vulnerable? So there is this tool called Snyk, which you can use. It's a platform, but it's also a tool. Like you can do it for the enterprise. It costs money. And you can do it for yourself. It's free, whatever. But the really cool thing about it is Snyk is a company that is able to really focus on security researching. And I think they have like the largest databases of security vulnerabilities. So when you are trying to figure out if something is insecure, you're going to find it pretty quick. The way it works is pretty easy. You can integrate it in your CI. I can tell you that I've been doing that for a long time, like over a year, also at work as well. So part of our CI, when someone creates a pull request, we're running this Snyk test tool. And if, for example, he added this malicious package that included like a RDoS attack or whatever, the Swig, the Snyk, something else, Mocha is vulnerable, whatever, it fails the build and we know about it, right? And at this point, we can go and ask ourselves, can we find a different package or can we maybe patch it, which is something really cool that happens here. So maybe just the last demo. All right, so imagine a use case, a story where your product tells you, I need to build this markdown parsed memo thing for my app. So right now it's like, hello JS day Italy, but it's like plain text string, and what instead you would have wanted is something like, I don't know, I'm just making this up as I go, so probably not the right one. But it's not really a link, so you need to make it markdown. So as a JavaScript developer, you're not going to write markdown parsing. You're going to go to the npm and find one, right? Makes sense? So I have one already for you. I installed it. It's called Marked. It has like, I don't know, 1 million downloads a week. Makes sense. I will use it. Let me enable that. And I need to use it, so just drop it here. Right, so I need to initialize it, and I'm gonna be safe, and I'm gonna tell it marked sanitize true. So it's gonna sanitize all the XSS stuff. All right, let me so you guys can see it. And then I'm gonna need it on my view side, so I'm gonna make it available in my view, and then I think that's the one. And I'm gonna wrap this memo code with marked, so it's actually able to parse it. No, let's just do it from here. Relog in, go to, sorry, yeah, that one again. Go to memos and yay, right? Markdown works. Again, works, ship it to production. So what if we try to trick it and give it a different kind of XSS attack over here? So something like, you guys able to see it? Right, the classic one. So looks good, right? Looks like it's doing its job. But there's actually a string that we found that is able to kind of circumvent what marked is doing and inject it. So if you use HTML entities instead of this colon, and instead of this one as well, to kind of close it, and then you add this behind between the characters, the browser is kind of gonna go and say, well, I know there's an entity and I see like a valid JavaScript expression, so I'm gonna just go ahead and render it with whatever the entity stands for, and then marked will not be able to overcome it. So when I'm doing that, I have circumvented XSS for marked, right? So again, I'm using a library that I got that is very popular, but it has this vulnerability that maybe some people know about that can go ahead and mess up your system. So this is, for example, one thing that you can find with Snyk, because if you hadn't used it, you haven't used Snyk before, you go ahead and use marked. You think, hey, this is good, let's go to production, I'm good, feature is done. But if you had run Snyk on it, you've seen that there's an actual vulnerability documented around it, and this is like all the vulnerabilities for marked. I guess there are some more recent ones, but you can see that this is, there's one of them over here, okay? So without going into too much into Snyk, it's basically allowing you to, like, the cool thing about it is if there isn't a fix from it, you can have you can add a patch. It's actually patching. They also provide patching for security, so it's actually patching your code in production, even if the author hadn't released anything or isn't even fixing it for you. So it's pretty cool. I would just say, like, go ahead and figure it out. And like I said before, for myself, like I suggest also like integrating those stuff into your ops. So like in your CI, Travis, Jenkins, whatever you guys are using, just go ahead and think about shift left in security. Test everything in CI, automate it. There are already tools that will help you do this. So we're maybe like done in a second, and just want to summarize all of the points that we talked about. So employ security headers for HTTPS and other stuff. Go ahead and be mindful about noSQL injections. And this kinda is related to like input and output encoding, validation. Do the best practices there. Avoid writing your own regex, right? Try to see if there are better solutions out there than what you're writing. And you can either use Snyk or just figure out some other way to just automate your dependencies vulnerabilities management. So thank you very much. I'm here if you want to talk to me.